Kia ora, Year 12 and Year 11. This is just a quick video going through 4 examples of integration by parts to give you more practice. And it goes with Chapter 8E and 8F. I don't think the questions are out of there, but I'm going to quickly flick through the 4 questions in this video for you to have a look at. So here's the first one. Here's the second one, the third one, and the fourth one. So that fourth one is one where we've got to do repeated integration by parts. So it's a little bit fiddly, but something we've got to get confident with. So let's go back to the first one. I'm looking at this and I'm going to decide which of the 2 functions I'm going to differentiate eventually. And it's going to be this one. Oh, whoops, pen's not working there. This one here. The first part of it, I'm going to leave this one and then I'm going to differentiate it. And the x is the bit that I'm going to integrate and then integrate. Usually this is different, right? Usually we end up differentiating the x, but here we can't integrate the log easily. So that's the bit that we differentiate. Hopefully that made some sense. Let's get started. So first we integrate the x and we get x squared over 2 and we just leave the natural log alone minus the integral of the integrated x times the derivative of this, which is 2 over 2x by the chain rule. So that gives me x squared on 2 log of 2x minus, now what have I got here? Well, I'm going to write this out again. I've got a half x dx, giving me the first bit. Sorry about the stylus, I don't know why it's gone so bad, but there you go. Minus 1/4 x squared plus c. Now I could factorise that more, but I'd give that line a big tick. We could also do this. We could go 1/4 x squared times 2 log of 2x minus 1 plus c. So that would get an even bigger tick. Right, so that wasn't too bad. It's just a matter of identifying which one is which. If you're watching this and you haven't gone through my notes on integration by parts, you're probably wondering what on earth is she talking about. So go hop onto Google Classroom and make sure you've worked through the first few pages of handwritten stuff. Right, example 2. So I like this one because it gives us just a bit of practice with definite integrals, but they work in exactly the same way. So this time, this x here is going to be what I either leave or diff. And the sine 2x is going to be what I integrate both times. So we're integrating and we've got limits, so we're going to be doing our definite integration. So we've got x here, we're going to leave the x, and then we're going to integrate this. So it's going to be, leave a gap, cos of 2x. Right, now when I differentiate this, I get a 2 popping out. So I need to divide by 2 to undo that. And when I differentiate cos, I get negative sign. So it's going to be times that, negative a half. And then we're going to evaluate that at pi on 2 or 0. I'm not going to work that out yet. I'm going to keep on going here and write down the rest of the integral. This time we're going to differentiate x and we get 1 times negative a half cos of 2x dx. Now, cleaning that up, what do we get? I'm going to do all of the work first, I think, before I start doing anything. So we get negative x on 2 cos of 2x from pi on 2 to 0 plus 1/2 times, so what I've done here is that's that negative and this negative, that gives me the plus, and I'll take the constant out the front. Now I've got to integrate cos of 2x. So that's going to be sine of 2x times 1/2. And that's being evaluated there. Now, some people like to put these together in one big integral. I think it's fine to leave it how it is, especially when it's quite a simple one in here. So we'll do them as two things. So this first one is negative pi on 4 cos of 2 pi on 2 is cos of pi minus 0, right? So it's minus 0 because it's that term is 0 plus 1/4, taking this out, of sine of pi minus sine of 0. So cos of pi is -1. So this bit here is just pi on 4. So it's pi on 4 minus 0 plus 1/4 of 0 minus 0. If you think about your sine graph. So see, all that work we did on trig has paid off really well because that question hopefully didn't feel too bad. So my final answer is just pi on 4. Right, we've got 2 left to do. So this next one is another definite integral, and it's just the integral of the natural log of x. Now, I think I might have done this one in class, but I did it as an indefinite. So here, the trick is to say that this is the same as the integral from 2 to a half of 1 times the log of x dx. This is going to be the thing that I leave or differentiate, and this is going to be the thing that I integrate. Nope, that's completely wrong. Forget that. This is going to be the thing that I differentiate and leave, and this is going to be the thing that I integrate. So when I integrate 1, I get x, and I leave the natural log, and I evaluate it at those limits, minus the integral from 2 to a half of x times 1 over x. So I'm now differentiating this log dx. So that gives me this integral. Just move that up a bit, minus this integral. So this becomes 1. The integral of 1 is just x. Right, now evaluating that at the limits gives me 2 log of 2 minus a half log of a half minus 2 minus a half. So let's clean this up quite a bit. We've got minus equals 2 log 2 minus a half times the natural log of 1 minus the natural log of 2 minus 3 over 2, which is 2 log 2 minus 0 plus a half log 2 minus 3 over 2, which simplifies to give me 5 over 2, right, coming from here and here, 5 over 2 natural log of 2 minus 3 over 2. Right, so that's my final answer for that one. Right, I've got one question left to do, and I'm hoping it's not going to use a whole lot of time, but it might do. So it's this one where we've got repeated integration by parts. But it's not really that hard. We can see here that this is going to be the thing that we integrate. And this is going to go bouncing back and forwards between a sine and a cosine function. And this thing here is what we're going to either leave or differentiate. But because it's a cube, it's going to take a few goes to come down from a cube to a squared to a linear. Right? So you've just got to be patient with this and try to set your working out neatly. I'm trying to make the handwriting better, but I'm not sure why the stylus is going a bit weird. But let's get started. So this thing here, I'm going to leave. It's going to be x cubed times, now the integral of sine x is negative cos x, right, minus, differentiate this bit now, so minus 3x squared times the integral, which is negative cos x dx. So far, so good. It's really easy to get a big mess with your signs when you're doing these ones. So I think it's worth cleaning up the signs now. So we've got plus this integral, 3x squared cos x dx. So now we go to work on this one. We do on this one here. We do IBP on this. This is what we're going to leave or differentiate, and we're going to integrate the cos of x. So just keep that nice little bit at the front sitting here, and then off we go again. Right, so we're going to leave the 3x squared, and we're going to integrate the cos of x, which is sine x. And we're always checking our signs when we, signs S-I-G-N, when we're looking at trig integration, right? So sine of x differentiates to cos x minus the integral of 6x sine x dx. So now the nice worked out bit at the front is negative x cubed cos of x plus 3x squared sine x minus, and we'll do IBP again. We're going to leave this. 6x sits there. The sine x gets integrated, and that's going to give me 6x times negative cos x minus the integral of 6 times negative cos x dx. Right? I really hate how that's gone off the line. Just going to make this pen a little bit finer, just a sec. Okay, now we've got to clean up all those negatives or we're going to have a huge mess. So we've got equals negative x cubed cos x plus 3x squared sine x plus 6x cos x. So just looking, this thing here is a times sign, right? Non x. So 6x cos x. Now here, I've got a negative, and I've got another negative, and I've got a negative. So I end up with, where's the pen? Pen's gone. Minus the integral of 6x cos x, or just 6 cos x dx. So we're just about done. So equals negative x cubed cos x plus 3x squared sine x plus 6x cos x, and we want to have minus 6 cos x, so it's going to be minus 6 sine x plus c. Now, I've never seen an A-level question where you had to do IBP that many times over. It's partly because it's just getting tedious, right? But it is good practice at just getting very fluent with your trig functions and with trig differentiation and integration. So that's the final answer there. Just make sure that when you've done it that you haven't mucked up any of your negative signs, and if you have, just go back and start it again. Okay, that was longer than I had hoped for, but gives you a little bit more practice at IBP. Remember, 8E and 8F are really important exercises, so do make sure you try lots and lots of them. Thanks for watching.